Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize similar functions as being transformations of their parent functions and how to understand the functions of trigonometric functions and transformations of their graphs. How are we learning it? Through the Trigonometric Functions notes and the Trigonometric Functions assignment. When can we use this information? To recognize the similarities between problems and understand how their solutions might also be similar. How do you know you learned it? By getting a score of 4 on the Trigonometric Functions assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Trigonometric Functions notes, and I'll give you time to complete the Trigonometric Functions assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Families of Functions study guide and any incomplete assignments that you may have. Let's take a look now at the Trigonometric Functions notes. The notes begin with the learning goals and success criteria. Now, what are the trigonometric properties? The first one we call sine. And sine is the opposite side over the hypotenuse. So it's a ratio of the side lengths with the opposite side being on top and the hypotenuse length being on bottom. Now, cosine is adjacent over hypotenuse. So we have our near side that will take that length over the length of the hypotenuse. Now, tangent is opposite over adjacent. So it's the length of the opposite side over the length of the adjacent side. The way we can remember this is SOHCAHTOA. So SOHCAHTOA is the easiest way to remember it. So is sine, opposite over hypotenuse. Ka is cosine, is equal to adjacent over hypotenuse. And TOA is tangent, is equal to opposite over adjacent. Now, how do we use these trig properties? So let's say I wanted the sine of, we call this theta. So we want the sine of theta. So sine, remember, is SOH, cosine is CAH, and tangent is TOA. So we're going to take this and we're going to go opposite, which is 4, over the hypotenuse, which is 5. So the sine of theta is 4 over 5. Now we have the cosine. So the cosine is the adjacent over the hypotenuse. So the adjacent side is here. So this is 3 over 5. And tangent is opposite over adjacent. So the opposite is 4. And the adjacent is 3. So it would be 4 over. Now let's take a look at sine functions. So sine functions, typically, unless they're slid over, they pass through 0. So they pass through the origin. And then they go up to 1, come down to -1, and then come back up to 0, and then continue on. And this continues on forever. This is a periodic function. So this is what the sine function looks like. Now, cosine looks very similar. They are just opposite. So they do the exact same thing. They follow the same pattern. Usually it's just slid over a little bit. And then tangent makes this kind of funny S shape, like this. And notice it continues on over and over again on each side. So it basically goes through its S and then starts over on the other side of an asymptote and does it again and again and again and again. So what is a period? A period is the distance a function travels before it starts to repeat itself. So periods can be measured in distance or rotations, written in degrees or radians. So in this case, we're going to recognize the period. So we start here at 0, and when do we return to 0? Well, we return right there. So we would say that our period of this function is 2 pi, because every 2 pi we go back to where we started. And you could pick any location. I could start here and go to here, and again, it's still 2 pi. From here to here, still 2 pi. From here to here, still 2 pi. So no matter where I pick, what point I pick, it's going to return to itself every 2 pi. Now, how do we alter a periodic function? So we start with y equals sine x. And if we were to take that and say y equals 2 sine x, that's going to cause a vertical stretch of 2. So now, instead of going up to 1, it's going to go all the way up to 2 and then come back down. Y equals sine x minus 1. So if we just take a minus 1 and add that to the end of it, that's going to shift it down 1. So it's going to take the whole thing and slide it. Then what if we had sine x minus 1 all together? That's going to be a horizontal shift to the right 1. And then if we were to take 2x inside the parentheses now, that's going to do a scale factor. Notice anytime we have these parentheses, we're always going to go the opposite of what you would think. So instead of multiplying by 2, we end up dividing by 2. Instead of subtracting 1, we really end up sliding to the right or adding 1. So anytime it's in the parentheses, it always goes opposite. But if it's outside the parentheses, it does exactly what you would think it would do.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the Trigonometric Functions assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. Now the activity begins with the learning goals and success criteria. We'll go ahead and click Next. Now for each of these, we're going to match the graph with its actual equation. And you can graph these in Desmos to try to help you, but we should be able to use the parts that we know. So for instance, we have sine x plus pi over 2. So we know that adding anything in here is going to create a vertical stretch. So which one of these has a vertical stretch? Well, this one is slid over, so that's not it. This one here has a stretch as well, but it's dropped it down a lot. This one here has a vertical stretch, and this one here has a vertical stretch. So it's going to be one of these two. So we just need to pick out which one it is, and it should be this one here. So we match those up. Now here we're going to have a horizontal stretch, so it's going to stretch and make it wider. And then we're also going to shift down 1. So which one is that? Well, that looks like this one here, so we'll go ahead and drag that and drop it there. And you'll match each of these up. And then when you're done with that, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.